All right, let's get started. Good afternoon, everyone. Looks like people are still trickling in. My name is Craig Currim. I run solutions engineering for transit security globally. And today we're going to talk about passwordless and zero trust within the enterprise. And what I thought I'd do today is not just talk about, theoretical stuff, but actually take you through an actual implementation or journey, if you will, of something that was just done for a very large global customer. So that you can actually see the technology as it's applied. And if we have time, hopefully we do, I'm going to show you a demo as well, okay? So let's set the stage in the background of the company that we worked with, a very large financial institution. Many different products offered by the company itself, client-side facing products, retail, commercial, you name it. Very, very large customer base as well as employee base as well, okay? And like every other financial institution, very regulated. The business case at a high level, just starting off, we've all seen these. 4 bullets: improve security, risk avoidance, and that's where you get into some of that zero trust stuff, right? Continual or constant assessment and authorization throughout the entire experience. Call center impact, specific in this case for internal users and employees. And then, of course, at the end of it, tying it all together and bettering the user experience. So you want to get rid of those passwords, stop making requirements to change passwords every 30, 60, 90 days, and reduce the impact on the call center. Lots of requirements, so let's dig deeper into this. Authentication requirements, so one of them was using the mobile device as an authenticator. Now, in some of the instances, we'll talk about their user base, but people were allowed to bring their own devices. In some instances, the company issued devices. In some instances, they weren't allowed to use a device at all, right? So all of these were considerations, both for primary and secondary, first factor and second factor login, okay? Or usage, rather. Delivery options within the mobile. In some cases, they wanted a standalone authenticator app that they could customize. In other cases, they actually had an app that was already distributed to the user base, and they just wanted to add the functionality in, okay? Now, what I'll add to this also is use of different types of authenticators, right? FIDO is definitely of interest and usable, but not good for all use cases, right? They wanted to drive specific user journeys and force certain types of FIDO authenticators. And as we know, the FIDO protocol, I can say use a biometric, but I can't dictate which one. Okay, I can't track which one. I can't lock it. I can't restrict it, right? That's a piece of the protocol itself. So there were some challenges, and they wanted to be able to use FIDO in some instances, local authenticators that were non-FIDO in others, and even central authenticators. We'll talk a bit more about that, okay? Elimination of passwords. Obviously, we know this. It's the weakest link. They don't want to use cached credentials, and they don't want to even use it as a fallback. It's just a bad option, okay? User populations all over the map, right? Traveling users, workplace users, like we said earlier, phones not permitted for some of the employees, consultants, remote employees, and we'll talk about two different types of methodologies for actual access, different types of permissioning that they wanted to or they needed to address, okay? Now, talking about the deployment of this infrastructure, the first phase included within a data center, but like everybody else, they're looking to go to a cloud model. They didn't want to be shackled to one vendor. So they wanted to be able to deploy across or basically have an infrastructure that would be adaptive to any cloud infrastructure, whether it's Azure, Amazon, Google Cloud, shouldn't matter, okay? Worldwide distribution and also cloud applications, right? Salesforce, Workday, you see the list here. So all of this was fair game, pretty broad requirements here. Now, the environment itself was heterogeneous with respect to user IDs and passwords, right? Different types of apps. They did have federation in some cases and SSO, but passwords were also issued for numerous applications, different usernames and passwords. And they had a project where they had looked at, having kind of a GUID or a global user ID. And just to pull all of that together was incredibly costly for them. They were failing at it, okay? Now, access points we talked about earlier within the enterprise or to the enterprise, everything and anything. VDI environments, Citrix, VMware Horizon, VPN requirements across the board, right? These are all elements that they wanted to address with the solution. Now, what's part of this, right? Because we talked about getting rid of passwords, but at the same time, we want to authenticate intelligently. What does that mean? So this builds into the zero trust model. We want to look at contextual parameters dynamically at runtime, okay? This is different than UBA, right? UBA is offline and after the fact, historical. You can use maybe some elements of that, but you need to be able to do a runtime decision. Users coming in right now, what are the conditions? What are the machines? What is the user actually trying to do? And make an assessment and drive the right user experience, applying the right authentication or permissions, okay? So they wanted this continual real-time assessment. They wanted adaptive entitlements on the fly, not just static at login, applying the step-ups where needed. They wanted pre-auth. So this goes to the user experience thing. If I know Craig is logging in and I know the mobile device and I know the desktop and Craig is coming in from, the locations and his IP addresses match what he's had before and looking at all these different signals, then maybe I don't need to apply the friction to Craig. Maybe I'll allow him a more seamless experience, right? So how do you do that dynamically and on the fly? This is what they wanted. And then follow the user. I should be able to normalize the data. So regardless of the channel that I'm using in the enterprise, there should be some kind of orchestration layer, this is what they wanted, that looks at and says, okay, how did Craig come in with the mobile app? How did he come in with the cloud app? How does he come in with the desktop? What information can I gather across that? Hey, he's failed authentication 4 times on the mobile. How do I want to treat him the next time he comes in on the desktop, right? So following the user's identity across the different channels and profiling that, okay? So what did the evaluation process look like? It was quite stringent and took a long time. There were 22 vendors evaluated in total, okay? Basically everything from cloud vendors, firewall vendors, you see the list here, FIDO only, niche vendors. And then there was also a next generation, platform vendor that provided all of the above, kind of, all stitched together, right? IAM, anti-fraud, and authentication. So this was kind of the gamut. Each one had a process. Each one had, I think it was 8 or 9 different use cases that they had to demonstrate and achieve as part of the evaluation process itself. Okay. Conclusions, and we gathered this from the customer themselves. The larger vendors that were either incumbent or they looked at, I won't say they're simple and trivial. I'd say they were legacy. Their capabilities were somewhat legacy, and they couldn't really adapt to the new, more advanced use cases. There were bolt-on components that didn't really lend themselves very well to what they wanted to do. So, not being able to support heterogeneous environments, hard to support cloud environments, taking an appliance and just, making it software and putting it in the cloud doesn't mean that it's cloud ready. It's just running in a data center somewhere else, but it's still anchored to the data center, right? Having something truly cloud ready that can span clouds is a whole different type of architecture, right? So the final decision was, hey guys, we can use this one vendor that's able to do this and it's purpose built, or we can build it ourselves, okay? So piecing together multiple options. Now, that's fine, but look at the long term of that, right? If I'm building it myself and I stitch all these components together, what happens when something new comes out? What happens when I want to make a change, right? Part of the sell here was all about being adaptive to future needs as new authenticators come out, new process comes out, new tools on the back end come out. I should be able to adapt to those without doing development projects every time, right? So the final choice was based on total cost of ownership over time. They wanted a single vendor support. They wanted one purpose-built platform to be able to do most of this and act as the foundational component. And they wanted overall to abstract that identity logic from their apps where it was all hard-coded into this platform where they could do everything basically in software defined, okay? So the solution architecture, let's talk a bit about this. And here it is, right? So we'll start with the middle, okay? The heart of the system itself, it's all about decisioning and orchestration. Now, orchestration, you hear this term so many times, right? It's a buzzword. How do we define it? How do we think, or how did this customer think it should be defined? It's looking at a series of different types of signals, and those signals can come in various inputs. They could come in from the invoking application. They could come in through the back-end systems that you see connecting to the Identity Services Hub, they could come in through operational data that's gathered by the orchestration engine over time, right? So we're orchestrating across those signals, and the word learning is in there. What does that mean? Well, it should learn over time. It should start building a profile and closely start, if you want to go to the zero trust model, well, let's start looking at behaviors. Let's start looking at what users and populations do and building means across those and learn about that. And then you can be much more adaptive when something does happen that deviates. You want to apply the right user experience, right? You want to do that on the fly. So this is the heart of the system, is this orchestration engine. The Identity Services Hub allows for integration of legacy systems. So there's no identity infrastructure out there that's greenfield, right? Unless you're starting a brand new company. But it's really tying into directory services, existing authenticators or authorization tools or user directory stores or maybe fraud systems, right? SSO systems. Those things should be, they want it to interoperate. And maybe over time they'll phase some of those out, right? But in the meantime, it has to be business as usual. You have to have a way to actually do that. And then all of this orchestration that we're doing and all of the inputs that we're getting either through push or pull from those back-end systems, how do you build policy? Well, that's through the user journey design tools. So I'm not writing XACML scripts here, right? There needs to be a way through a user interface to actually build policy logic, build the decision tree, be able to adapt it, adding conditions and actions appropriately, and doing that all in a systematic way, right? So these are the user tools that they can use per application to design the journeys. And by the way, they can phase the journeys in as they see fit. So across user populations, across really demographics, any kind of decision criteria they want, this is part of the tooling, they can expose those specific journeys out, okay? Now, this is all done over the air. It's a marketing term, right? What does that mean? Well, we talked about taking that identity logic away from the apps, so the mobile apps, the web apps, Windows and Mac, and so on. Well, you have to be able to deliver something in real time. And the idea is that there's a one-time integration with this thing called a journey player that resides in these channels. What is a journey player? Well, we don't call it an SDK, we call it a journey player because an SDK is just a series of libraries that I would have to add app logic to query and use, right? And I have to associate those with user experiences and still have to do all the other security measures and encryption and signing and all that kind of stuff. A journey player automates all those things. So it not only takes those libraries, it has fabric around it that's able to do device information gathering, looking at everything, not just is it jailbroken, is it rooted, but everything about the device, hundreds of parameters, right? Anything queryable. What's the OS? What's the hardware version? Is there a secure enclave? Is the screen lock enabled? Is it Wi-Fi, accessing over Wi-Fi, cellular? Is it encrypted? Is it not, right? Pulling all of that context, right? And supplying that in as signaling information that then I can orchestrate around. Okay, so that's one element of the journey player. It does all of that for you. The second is that it actually contains UI elements that can be customized from the platform. So screens that get rendered as a result of policy, new authenticator screens, different types of things where we want to actually change the journeys. And this is where they saw a tremendous amount of values. When you do that one-time integration, you might have an idea of what your journeys are today, but how about tomorrow? You see some new fraud vector and you need to change. You want to supply an information screen to the end user. You have to go back into the app. Well, with this architecture, you don't. The journey player coupled with the over-the-air system and the user design tools will let you do it from the platform. Okay, now coupling all of the risk parameters with authentication, right? This goes back to continual risk assessment. It's broken down into 3 areas. This is the way the design is done. So we've got application session trust. What's the user doing in the app? We'll show some examples of this. Device level trust, authenticator level trust. And for each one, you've got attributes, you've got profiling, which is done by that operational database we talked about, and events that might happen in real time, okay, that then get added to the profiling as well. So let's give some examples of this. Authenticator trust. You can assign authenticator levels, and this is why this has to be dynamic. First of all, I want to supply, or they wanted to supply different types of authenticators, give the user a choice, right? And you don't know what the user's device is capable of. You don't know what the user has registered for, and you don't know what the user prefers. So I need to have a way to go in there and basically assign different levels to authenticators, and those should be dynamic. If Craig is coming in and he registers a fingerprint on an iPhone and he's using that for 6 months, maybe that's a level 200. Okay, now I register an Android device and I enroll a fingerprint. Is that a 200? I just did that. Maybe that's 50, right? It's not a trusted device yet. It's not a trusted modality. If I get the PIN code, I can enroll someone else's fingerprint. Is that even Craig in the first place? So authenticator levels, global threat indicators. There's different types of vulnerabilities that are found, right? So you should be able to adjust for this all in the Authenticator Trust scoring. Personal threat indicators. I know Craig logs in all the time with his fingerprint, and now he's failed that 3 times after 9 months, and he's using password, which he hasn't used in I don't know how long. What does that tell me? Well, it's deviating from the current use, and maybe I need to change the behavior and do something different with Craig. And then the sensitivity of the resource. So based on what operation they're trying to perform within the app, increase, use a FIDO, use stronger form of authentication, or use 2-factor in that case. Device trust, looking across the board. Maybe you're using an Android that's running an antiquated version of code and you don't want to give it the same permissions, or you need stronger authentication, right? OS versions, connection types, registration dates, all these things are fair game and they should be fed into that system to do dynamic orchestration, okay? And then finally, application session trust. What is Craig doing? How often does he log in? From which location, from what time of day, what resources is he looking, what are the applications he touches most frequently, right? These again become scoring, and all 3 of those can be weighted and they can be prioritized. Now this is a different model from your traditional black box risk engine. This allows, with machine learning, this allows baselines to be set and the customer to actually modify and weight accordingly, okay? This can also be coupled, as you saw with the other diagram, with external feeds from risk engines that maybe already exist. So you can basically use both of those and you can prioritize them. So how does the architecture look? Well, here it is, right? You've got the desktop environment with this customer, right? Now we have risk and orchestration through the platform. So all those dynamic abilities, not just for login, but anywhere in the flow. You're driving authentication services that could basically drive, whether it's on device, whether it's to a mobile device. This is the model. If you have web, same idea, right? Web gateway, internal web apps, intranets, etc. Same idea. And same holds true for cloud apps, sorry. So here you have a model that they can standardize on for all these things, okay? Now, those of you also know when most risk engines out there, they're just passive elements. They'll give you signals, they'll give you scores, but then you need to take action somehow. This platform, along with the journey player, has a control point on the endpoint, so it becomes actionable, right? Use a stronger authenticator, use a different factor, use a trusted device. I won't let you use that one. Maybe I need a device chain, so your device is not that trusted. I'll send a push to the device that is trusted. You need to key that code into the newer device to establish trust. All these things become fair game. Deny access, limit access, lock an authenticator, lock a device, right? So all of this now becomes a function of those user-defined journey tools in the platform itself. Now, the actual use case, I think this is the best part of it, showing the KPIs. What did the customer actually glean from this, and what happened in the short amount of time thereafter that they were deployed. So 90% reduction in call center from internal calls. Just the savings on this alone was massive, okay? They were able to end of life legacy authenticators. In this case, it was tokens because the platform offered it, right? Authenticators are all commodities at the end of the day. You should be able to snap them in and snap them out, and that orchestration layer lets you do just that, okay? Consistent user experience. They had Windows 7 machines, Windows 10 machines. They had Macs. Same user experience. They were able to educate and get the users to accept the new forms of authentication. And they had a problem with this in the past with Hello. They were tried using Hello for Windows. It was only available on Windows 10 machines, and so there was different experiences across the board. With this, same experience, okay? And of course, making the execs happy is always good, okay? So let me show you the demo. Can we flip to that? And this is all live. I say this ahead of time because if something happens, it's just a disclaimer. But what I want to show you is I've got my Mac here and I've got a Windows 10 machine. And I'm going to use 2 users here, okay? And what I'm doing is I'm intelligently using that platform in the background. User Craig is going to log in first. Now, the tiling that you see on the left-hand side is customizable all through the Journey Player, which can be pushed out through an MSI install, okay? And in this case, I'm leaving the password option. You can take it away altogether. But based upon the user's permissions and group, I've designed a policy, which took all about 3 minutes. And based upon if the user has a bound mobile device, I'm giving them different ways to log in. So for user Craig, if you want to log in, instead of using password, user Craig can come here and log in. And the option I get is to authenticate with a mobile device. Great. It's going to go look at that operational store, go look at bound mobile devices. It actually just checked that, or it wouldn't have presented me with this option. And it's going to go retrieve the push token. It's going to send a push through Apple to the end device and run a control flow on the mobile. There's the pop-up on my phone. Okay, I'll click that. Now I can drive whatever messaging I want. That's completely out of band. Here you have the desktop name, IP address. If I approve it, I'll run a control flow displaying the authenticators that are available for this user. Let's just use a fingerprint, place my fingerprint. The assertion is done in the mobile channel, and the platform synchronizes it to the desktop, and I'm logged in. No more passwords, gone. Same machine, I walk away, and I lock it, okay? Multiple users. User John is going to log in, and John does not have a mobile. So intelligently, the platform knows this, and what's going to be available? SMS, OTP over SMS. There it is, 07839. And now John's profile is loaded and off he goes, okay? So I just showed you 2 different authenticators. You can do this with anything you want. You can use authenticators on the desktop, UB keys, touch IDs, really anything that's offered through the mobile device or locally through the machine itself, all invocable from the platform. Okay. 2 minutes and 30 seconds left. So hopefully this was useful. I'll stop for questions. Yes? Yes, so the question was, do we support enterprise applications? Depends on the application. So for example, something like a mutual auth, absolutely, 100%, right? It depends on the application and how that application can actually invoke. So if it's a Windows-based application, or it's an application that uses the Windows authentication stack, then obviously that would ride on top of what I just showed you. But if they have their own authentication stack, then they could hook the platform in a different way. Okay. Yes?
So you showed passwordless. Hey, Craig, thank you.
Yeah.
You showed the passwordless login to the desktop, right? So what did you have to do to, it has something to do with the Microsoft behind the scene, right? So how was the integration with that?
It's a great question. So this is not a hack or a shim. What we actually do, when you push that MSI out, that MSI contains everything you need to install on the desktop. And as you all know, you can push that MSI through group policy, through GPO, right, from the domain controller. What we're doing on the desktop is we're utilizing PKInit, and we're utilizing Windows Smart Card services. So we emulate an actual smart card. There's no password. There's certificates. The certificate from the domain controller gets exported and stored on transmit, which is why we can operate in connected mode, disconnected mode when you're not even able to reach the DC, or even offline mode is also supported. Okay, so what's happening is the control flow runs, it invokes the system, the control flow runs, and then basically certificate is released on the desktop, but the hook is through Windows Smart Card services. You would have a login process on each one, but sure. Yeah, it would, no, it depends. And here's where I mentioned earlier, right? It's like, depending upon the authenticator that you want to use, if you have a centralized authenticator, you could use that across all the laptops. Or if it's a localized one, like a FIDO one, you'd have to make sure that that was enrolled on the machine. But yeah, you can hop around. question.
In your presentation, you showed 90% reduced CE calls. I assume that is 90% of the call related to login. And if so, what
Password
calls?
reset calls.
Password reset call.
That's right. Question was, yeah, I think everyone heard it was on the mic, so I'm used to repeating it. Yeah, of course.
So you mentioned something about the learning component. Is it AI based?
Yeah, you know, these words like AI and ML, I don't really like them, but yes, so there's machine learning. I wouldn't call it AI. There's machine learning that goes behind the scenes. Now, how does that actually work? It's a much deeper discussion. But think about it in the context of profilers as building blocks. So I can create a profiler on the system that says, hey, I'm going to look at Craig, and I'm going to look at his devices, and I'll look at his location. I'll build a heat map around that, and I'll look at the times he accessed, and I'll build a heat map around that. And that's something you can configure globally, and then you can apply in policy and say, look, if it deviates from this, then it's bad. What the machine learning aspect does on a broader scale is it automatically looks for relationships between different users. Now that could be something different in every case. Could be group membership, could be location, the demographic, it could be a number of different components. But as you know, with learning and ML, the greater the data sample, the more reliable the mean will be, right? And then when you see deviations from it, that doesn't mean block the user, you can just treat the user differently. So that's the machine learning that is in the system, and it will continue to progress over time.
The reason I asked that question is you have the policy definition component through the journey design tools.
Yeah.
But the learning component, does it nudge the user towards a better behavior? Like if the user is using user ID password, you know, after you establish some level of trust on the device, maybe nudge the user to start leveraging a stronger form of authentication and so on.
That's right. So it can do all of those things. So you have a decision to make, right? So as you release different authentication modalities, all as part of the user design journey tools, you can offer the screens and offer the enrollment process, again, all driven through the journey player for the users. Now the ML can come into play there that says, okay, you know, Craig's been logging in and he's coming in through an authenticator that's kind of sort of weak. And you know, this is kind of the profile he has. So you could take that output and actually drive a new experience for the user that when he logs in or she logs in, they get prompted and say, hey, why don't you enroll in facial? Okay, you'll be able to be exposed to more functionality inside the app. You can absolutely do that.
Thank you.
Yeah. Okay, so the question is, do apps have to change or are the journey players custom? The answer is they're not custom. Apps have one-time integration. So as I mentioned, for Windows, it's a very automated MSI push, and there's nothing more that has to be done. The rest of the configuration is on the platform side. For mobile apps or for web apps, the journey player basically is realized through SDKs. So for mobile apps, you know, iOS is Objective-C and Swift, or Java for Android, and JavaScript for web. And these are standardized. So think of it this way. You're normally when you add different authenticators or different tools, let's say in the mobile or the web channel, everyone has a different API, right? You have to stitch all that together. You have to get the results from that API. You have to create the right screens for it. There's all these different points of integration that become security gaps, if you will, because the bigger the surface area, right, for all the connections, the more threat there is. With the journey player, it becomes a single integration and one point of invocation. You have 4 different calls: call, authenticate, call, assert, call, validate, right, are 3 of them. And now all of that is done in a very standard way. Everything else is a function of what you design in policy. So it's a one-time integration, but it's not customized. It's the same across the board. You just have to decide where in the app flow you want to invoke the platform, and it's that same call. So the question is if the web app or the mobile app is already doing OIDC, and the answer is it depends. So we absolutely have a full OAuth, OIDC, and SAML stack as well. So whether you want to leave that flow intact for initial login and then invoke transmit after that and invoke the platform after that, or whether you want to actually change the flow invoking the platform and having the initial orchestration, everything being done by the platform, and then having the platform invoke through an OAuth or an OIDC flow, the existing system, getting the token on behalf of the user, embedding it, and handing it back. You could do either one. It's a matter of design, really. Okay? Thank you, guys. Really appreciate it.